Poisson process. You see the definition. It is a discrete random process x of t defined in the interval 0 to t is called a Poisson process with rate lambda greater than 0 if all the following conditions hold. First one, x of 0 equal to 0. Second one, x of t has independent increment. That means the numbers of events that occur in disjoint time intervals are independent. That is, so first, for example 11, 9 to 10, the events happened on the time interval 9 to 10 is independent of the events happened in the time 10 to 11, like that. If you are going to a shop starting at 9 o'clock, reaching the shop at 9:30, after 9:30 you are purchasing something in that shop. So the moving from home to shop 9 to 9:30, the event independent of the event purchasing 9:30 to 10 in the shop. That is what. That is, x of t is independent of the number of occurrence of event in any interval prior and after the interval. The interval is 9 to 10 means prior means before 9, 8 to 9 you can take, say, or 9 to 10, that is what it mentioned. Third one, x of t has stationary increment. That is, the distribution of numbers of events that occurs in any interval of time depends only on the length of the interval. If you are going to shop means you are starting from home 9 o'clock, reaching the shop at 9:30. So the event depends only on the 30 minutes, right? 9 to 9:30, the difference is 30, right? You are purchasing in the shop from 9:30 to 10 o'clock. That event purchasing depends on the interval, time interval 30 minutes, right? That is what. The probability that an event occurs a specified number of times in t to t plus delta t depends only on delta t, but not on t, not depend on the starting or end time, right? Fourth one, probability of x of delta t equal to 0, that is equal to 1 minus lambda delta t plus o order of O of delta t. What is that means? We'll see. We know that the probability distribution of Poisson distribution is given by, we know that distribution is probability of x of t equal to n, which is equal to e power minus lambda t power n by n factorial. So we are expanding this using Taylor's expansion, because e power lambda, right? We can use e power minus lambda 1 minus lambda plus lambda square by 2 plus minus lambda cube by 3, etc., etc. That is Taylor's expansion for e power lambda minus lambda. So here instead of, we are having e power minus lambda t 1 minus lambda t plus lambda t square by 2 plus etc., etc. into lambda t power n by n factorial. So probability of x of t delta t equal to 0. So replacing t by delta t and n by 0 in that, right? So you will get 1 minus lambda delta t plus lambda delta t square by 2 minus etc., etc. lambda delta t power n, that is 0, divided by n factorial 0 factorial, which is equal to 1 minus lambda t plus lambda delta t by 2, etc., etc. that is equal to 1 minus lambda delta t plus higher powers of delta t, right? Powers of delta t power 2, delta t power 3, like that the terms are. So we are meaning it like order of delta t, right? So where order of O of delta t is the terms containing the higher powers of delta t, right? Next, fifth one, probability of x of delta t equal to 1, which is equal to lambda delta t plus order of delta t. Same, we'll take the Taylor's expansion. So we'll take instead of n equal to 0, we'll take n equal to 1. That probability of x delta t, which is equal to 1, which is equal to 1 minus lambda delta t plus etc. into lambda delta t power 1 by 1 factorial. So grouping this, we will get lambda delta t minus lambda delta t square plus etc. So we will get lambda delta t plus order of delta t, right? Next one, sixth one, probability of x of delta t greater than or equal to 2, which is equal to r of delta t. So this can be written as probability of x of delta t greater than or equal to 2 is nothing but 1 minus probability of x of delta t less than or equal to 1. That means 1 minus probability of x of delta t equal to 0 plus probability of x of delta t equal to 1. Right? So this is what 1 minus, so we are using expansion of each term. So we will get 1 minus first one lambda delta t plus lambda delta t square by 2 plus etc. Second one lambda delta t minus lambda delta t square plus etc. Grouping all those things, taking minus inside, you will get 1 minus 1 minus lambda delta t plus lambda delta t plus r of lambda delta t. So everything will get cancelled, you will get r of lambda delta t, right? Higher power of delta t. Next, probability law for the Poisson process. What is the probability? That is what lambda be a number of occurrence of the events in unit time. That is lambda is the rate of occurrence. So in a shop, how many persons are coming inside in a particular time? 9 to 10. That is what occurrence, right? Suppose number of occurrence is 4, 5 per hour. That is the occurrence, number of occurrence, right, of the event. Then the probability of exactly n occurrence in time interval of length t, say 0 to t. In 0 to t, how many persons are coming inside that particular shop? Is a Poisson distribution with the parameter lambda t. That is, we know p of x of t equal to n, which is equal to e power minus lambda t, lambda t power n by n factorial. N takes the value 0, 1, 2, etc. Probability of xt equal to n is denoted by p n of t, right? Mean and variance of the Poisson process. We know for Poisson distribution, mean equal to variance is equal to lambda t, the same thing. Then autocorrelation of the Poisson process, r xx t1 t2, we know expected value of x of t1, x of t2. So we will get expected value of x of t1 lambda square t1 t2 plus lambda t1. Expanding this is, we will get if t2 is greater than or equal to t1. If t1 is greater than or equal to t2, the formula is lambda square t1 t2 plus lambda t2. So anyway, r of x of t1 t2 is equal to lambda square t1 t2 plus lambda minimum of t1 comma t2. Not auto covariance of the Poisson process. Cxs of t1 t2, which is equal to rxs of t1 t2 minus e of x of t1 into e of x of t2. Substituting the values, we will get which is equal to lambda t1 if t2 is greater than t1. Yes, lambda t2 if t1 is greater than or equal to t2. That is lambda into minimum of t1 or t2. Properties of Poisson process. Additive property, sum of two independent Poisson process is a Poisson process. Inter-arrival time of Poisson process, that is arrival between first one and second one, that is the inter-arrival time. That is in a shop, the arrival between first customer and the second customer, right? That is the inter-arrival time with parameter lambda as an exponential distribution. That is main thing with mean 1 by lambda. Poisson process is a Markov process. Difference of two independent Poisson process is not a Poisson process. That's all. We'll see in the next. Thanks.